will have sufficient kinetic energy to escape to infinity here in all directions. Don't bother anything. I just shown previous problem along exactly in all directions. The photoelectrons will just escape to infinity in all directions. Then how long this will occur? As the photoelectrons continuously escape from the shell. Escape, I'm using word, not just ejected. Escape from the shell. The charge on the shell will build up. Then as the charge builds up, there will be electrostatic field will be generated. And that electrostatic field, what happen now? Will try to retard. Then at one point is reached where the kinetic energy of photoelectron will not be sufficient to escape that electrostatic field. Then what happen? It will retrace path. The ejected photoelectron will retrace path. It's a very generalized question again. Just previous problem what we discussed, the same thing here. Continuously here, radiation will be incident. And here is what I'll show now clearly. What is this blue color? This is the electrostatic field. Who will set up this electrostatic field? As the photoelectrons, they escape to, when they escape to infinity, the net charge will be built up here. So this is the E bar. You put like this. This is the way what happened you are supposed to think here. Now this electron, when it comes here, it will experience a force like this, electrostatic force. So initially it escaped to infinity. After some time what will happen? It will retrace path here. Okay, just will show one of the. After some time. So that retrace is what I'm just trying to show it here. Before reaching infinity only, it will come to, again it will come to rest and will return back. So therefore a net charge will be built on the any same question I'm trying to put so that you can understand it clearly. So this acquired a potential, no? This has acquired a potential. So what is asking? It acquires a potential of, so K max should be equal to charge of electron into that potential. So what is K max is equal to? SC by lambda work function. That capacitor, all you'll get scared. So don't just fun. So this will be the thing. For previous question, if you close the switch, the charge on the capacitor after a long time. All of you able to hear me? Voice clear?
Yes, sir.
I think check from your end. Somebody is saying that voice not clear. I think you have to check your connection only. Yeah? Okay, now let me continue. Everyone is saying it's clear. Huh? I'll continue the class now. Okay, now this is about the potential of shell. So is asking next again. For previous question, if you close the switch, when it is closed switch, after it is acquired potential, is going to close the switch. Then what is the charge on the capacitor? After a long time again. See, in that case, what happens? This shell you treat like a. This shell you treat it like a capacitor, because this is like a. This is a capacitor, no? You treat this is like a source. So what is this? This is a shell. What is the potential of this shell? This much here. After a long time, then this will acquire a charge Q minus Q. So then what is the potential difference? C into potential of This one. Agreed. This should be the equivalent diagram. The shell you treat like so. Why you are putting that source of EMF? Why you are putting that source of EMF? So in any how you justify your answer by showing that as source of EMF? The incident wavelength, here photons will come, they will strike this, and the photoelectrons will not escape to infinity here. In this case, will be there only. The photoelectrons they'll be ejected. I'll put explanation my explanation. The photons are incident. The photoelectrons are ejected, and they'll not escape to infinity. They'll return back. Then these photoelectrons open. They have a path. No, the ejected photoelectrons. This path is there. The path is what provided by capacitor. So now the photoelectrons which are ejected. So what will happen? They'll go there. They'll try to escape to infinity. They cannot escape. By the time when they come here, what happen? They'll go like this. And negative charge and the photoelectrons will go and deposit here. Positive charge will be deposited. Then electrons will come here. Positive charge will be positive charge, and next electrons will go like this. So like this, what will happen now? What will happen to the charge? The number of electrons on this, shall I say that will keep on increase? How to justify this? How long the flow of charge will occur? So in fact here, the photoelectrons, what will happen? After long time, again I think you should make the problem a little bit very clear. After long time, what will happen is again, this will be how many the photons are incident, the photoelectrons will be ejected. The ejected photoelectrons will happen instead of reaching to infinity, what happen? They'll go like this. Means then continuously photoelectrons will keep on come. How long this flow of photoelectrons will take place here? Till the potential difference across capacitor is less than that of shell. Once potential difference across the capacitor is becomes equal to that of shell, no more further flow of photoelectrons will occur. Will I agree this? So that is what is telling that one. Now please try to understand. For phase go, if we close the switch, the charge on capacitor after a long time. So what is the meaning of this? The light is incident. I'll close the switch. The photoelectrons will some will escape. Let's say that. So here, so there's a path for them to flow. No. So they'll get deposited in capacitor. How long this will occur? As long as when the potential of shell becomes equal to potential of capacitor, the further flow of photoelectrons will stop here. And that is what is happening. I think just I'll put equal to this much here. Okay.